Welcome to Pomodoro Joe for Sunday, May 21st, 2023. Today we're looking at LeetCode problem 934, shortest bridge. This is a medium problem. You are given an n by n binary matrix grid where 1 represents land and 0 represents water. An island is a forward-directionally connected group of ones not connected to any other ones. There are exactly 2 islands in the grid. You may change zeros to ones to connect the 2 islands to form 1 island. Return the smallest number of zeros you must flip to connect the 2 islands. Okay, well, we'll put 25 minutes on the Pomodoro timer and we will get started. So we'll start with some result. And let's see, we're already told that we start with 2 islands and they have to be connected by at least 1 new piece of land. So we can start our result as 1. At the end, we will return our result. Okay, so I think this will be a fairly standard graph traversal or grid traversal, but with a little bit of a twist. So the first thing I think we need to do is actually find our 2 islands, or at least find one of the islands. So right now, if we just build some bridges and we hit land, we don't necessarily know if we hit the other island or if we hit the same island at a different place. So let's actually find our first island. That way we can just try to go from that island to any other island, which there's only one other island, so that'll be the other island. Okay, so to find our first island, we'll just find our first piece of land. So let's do that. I'll actually create a new function for that. First land. Okay, and we'll just go for X, or we'll start Y in range. We want our N here, so let's get N, and we'll make it a global out here, and this will be the length of our grid. Now our grid is an n by n grid, so we can use that for both X and Y. And then for X in range N, now we just look for land. So we'll look at our grid, at this, and it'll be Y and X. It doesn't really matter, but typically I use screen space. So that means that the upper left corner will be 0, 0, and Y will increase as it goes down. So those are the rows, and X will increase as it goes across. So those are the columns. So now we just need to check. If the grid at this point is equal to 1, then we have our first piece of land, and we'll just return this X and Y coordinate. Let's see, we'll return that as a tuple. Okay, so we'll set our start to the first land. So now we have our starting coordinate. This is just the first piece of land we've come across when we're traversing our graph. So we'll just use this as our start point, and we'll go through and find all the land that's connected to this piece of land. That will define our first island. Now, I could do a couple things here. We could go through and actually change the value in our grid to something like 2. So all of those pieces of this island will be now labeled 2. Or we can just put them in a set of visited cells. So I think that's what I'll do. I'm just going to keep a set of all the different cells we've visited. So for this first pass, that will just include all of the land that's connected to this first piece of land. Then we'll continue using that same visited when we start building our bridge, but we'll get to that in a minute. So our visited will be a set, and this will be a set of tuples, and those tuples will contain XY coordinates. All right, and then we also need a queue. So this will be the land that we'll be processing. So this is kind of where we get into the standard graph traversal or grid traversal. So we'll have some queue. That's going to be just a list, and we're going to start with our start piece of land. Let me do this. Okay. Now, while we still have something in our queue, we will pop something out of the queue. That'll be a cell of land. Then we'll look for all of the adjacent land cells, put those in the queue, and keep popping those until we run out of land cells. So that should exhaust this entire island, and that entire island will then be in our visited set. So while we have some queue, let's grab the first thing out of the queue. So we'll say it's the cell, and we'll just say queue pop. And I'll actually go one better. Instead of calling cell, we already know it's a tuple with x and y, so we'll just say x and y equals q pop at index 0. Now we'll add this cell to our visited set. Oh, now that I think about it, maybe it is better to keep this as a cell because we're going to be adding it to our visited set. So let's just do this. So we pop our first piece of land, add it to our visited set. Now we have to look for the up, down, left, and right cells. So let's do that. Now at this point, actually having an x and y would be helpful. So maybe I'll create an x and y here. So up direction. Now remember, I'm using screen coordinates. So my upper left corner is 0, 0, and y increases as we go down. So that means y will decrease as we go up. So our up will be at the same x, but at y minus 1. But this only works if y is greater than 0. So I will say if y is greater than 0, else we don't have an up direction we can go to. Now with down, it'll be similar. We'll go x but y plus 1 because y increases as we go down. And that's if y is less than n minus 1. So we can get to n minus 1, but we can't go past n minus 1. Otherwise, we're at none. And then we just do the same for left and right. Okay, so now we have our up, down, left, and right coordinates from this xy coordinate, and we'll put those all into one list so I can go through them pretty easily. So these are all my options. Okay, so we've got my left, right, up, and down in my list of options, and now we'll just go through all of those options. So for every option in our options. Now the first thing I need to check, some of these could be none. So if we don't actually have an option, we'll just skip this part. Okay, now the next piece, we'll check to see if it's already been visited. If it's already been visited, we don't need to do anything. Otherwise, we will add this to the visited cell list. Let's actually clean this up a little bit. So now we're looking up, down, left, and right. This is one of the options we're looking at, and we need to check to see if the value in our grid is another piece of land. If it is, then this is part of the same island. If it's water, it's not part of the island, and we'll move on. So let's see, we'll actually grab our next x and next y out. And now we'll check the grid coordinate at this next x and y. Remember, y comes first, so we'll say next y and next x. If that's equal to 1, that means we have an adjacent piece of land. It's part of this island. We'll add it to our visited list, and we'll add it to our stack, or our queue, so we can go through and process this piece of land as well. So let's see. First, we'll append it to our queue. And now we'll add it to the visited list so we don't end up adding this multiple times to the queue. I think I'll also do a double check in here to make sure it's not already visited. So if it's equal to 1, maybe I'll just do a continue up here. This will be easier. If we don't have the op, or if op is in visited, then we'll continue. Okay, that actually helps. All right, check to see if we have land. If we have land, then we'll put this piece of land into our queue for processing, and we'll make sure it's been visited. And then we'll move on. Okay, so at the end of this whole while loop, we should have our entire first island in the visited list. Next, we need to find out where to start, basically our bridges. So I think what I want to do here, if we're going through this first island and we find an adjacent cell that's water, well, that can be a possible starting point for our bridge. So I'm actually going to check that here. So if this adjacent cell option is a piece of land, we'll be adding it to our queue for processing. Otherwise, let's add it to, I guess, let's have a next queue. So we'll have our starting next queue or our water queue. I don't know what we'll call this, but we'll call it the next queue. That'll be an empty list to start with. So if we're going through our first island and we found some piece of water that's right next to our first island, then that can be a starting point for the bridge, and we'll add it to our next queue. Cool. So at this point, we've got our first island in our visited list, and we have all of the start points for our bridge in the next queue. So now we have to do a second traversal, or a second grid traversal, where we start with our starting points, or this next queue, and we'll build out from there to try to find the next island. So let's do that. So our new starting queue will be just the next queue. And while we have something in our queue, so this will be very similar to our first one. So I actually might just grab this whole thing. All right, so we'll grab our starting point out of the queue, or we'll grab a continuation of our bridge out of the queue. We'll make sure that we add that to our visited list. Check the cell, get our up, down, left, right again. Now in here, when we process the up, down, left, right, it'll be a little bit different. We'll still check to see if we have one and it's not in visited. So that's going to be the same. But at this point, we're not looking for, well, actually interesting. If we find one, that means we found the next island. So at this point, instead of queuing up that piece and adding it to our visited list, we can actually return. But what do we return? We need to know the length. We don't have the length of our bridge. How do we keep the length of our bridge? Well, what if we just kept it with our cell? So instead of having this cell be an X and a Y, we'll also have it be X, Y, and length of bridge. So let's change that here. This cell will now be X, Y, and I'll call it B for the length of the bridge. Maybe I should call it L for length. All right, X, Y, and length. I like B better. All right, so we have an X, Y, and B. This tells us the length of our bridge so far, which means that this cell needs to be slightly different than our first pass. Now, when we append our next queue, we'll have to have the op plus some length, which means we have to start it at something. Oh, what do we start it at? Start it at 1, because it'll be length 1 to start with. So let's do that. So we'll start our tuple. It'll be, instead of just op, we'll actually have the next X, next Y, and then some length starting at 1. Okay, so now when we pop this out, we have our X, Y, and our current length. We can go through here. Then when we do get this return, we can actually return our length. All right, that seems pretty straightforward. But what if we don't hit land? If we hit water instead, then we do have to keep building our bridge, which means we also do need to queue up this next piece, but instead of just doing op, we'll have to queue up the X, Y, so this next X, Y, next X, next Y. And at this point, it'll be our bridge plus 1, because we've had to build one more piece of bridge. And I think we do want to add this next XY to our visited. So let's do that here. Just so we don't end up re-queuing the same cell multiple times. All right, at the very end, we do return this result, although hopefully we'll hit this return first, and we'll just return the length of the bridge. All right, that took longer than I thought, but let's give this a shot. And I totally broke something. I don't need this other if. That was bad coding. Try that again. Copy, paste. All right, as you can see, I already have some duplicated code in here, so we can probably clean that up too. I think a lot of this is going to be optimizing once we get the basics working. Op is not defined, so we're going to call this ops. Same thing probably down here. Try that. Let's see, L is not defined because I called it B for bridge. Next X underscore Man, I've been kind of off these past two videos. All right, we're passing. Let's submit this and see how we do. And then if we pass all the tests, I'll break this down really quick and we can go over it again. And we pass. In fact, we do crazy good. I did not expect this. We're beating 97.99% or 97.98% for runtime and 54% for memory. So that is like way better than I was expecting. Okay, well, let's take a quick look and break this down really quick. So we have to find the first island. That's our first step of this entire process. So we go through, we find our first piece of land. We just do a regular XY traversal of our grid. So we go through every Y and X just across the rows and across the columns until we find some land. We take that first piece of land and we're going to put that in our queue to start with. So we're going to start that. So our queue starts with that piece of land. We need to keep our visited list. So all the cells that we visited, we just visit them once. We don't have to visit them a second time. So we have this set of visited cells. All right, now we have this empty next queue. Now this is a little bit of an optimization, I guess, but this next queue will actually keep track of all of the coastline or the ocean water that is adjacent to our first island land cells. So these will be our starting points for our bridge. Then while we still have some cell in our queue, so some land in our queue, we're going to pop that cell out. We're going to make sure that we visit that cell. We add it to our visited set. And then we get the XY out of that cell and we find the up, down, left, and right from that land cell. Then for every direction we can go, up, down, left, or right, we check first, do we have that direction? Like, are we not outside the bounds of our grid? And also, have we not yet visited that cell? If we are outside the bounds or we've already visited that cell, we're just going to continue. Otherwise, we will take this cell, check to see if it's land. If it is land, then we'll put that in our queue to process later. And we'll also make sure that we mark it as visited so we don't end up adding the same cell to the queue multiple times. The next part is if it's not land, then it's water, which means that we're going to add that to our next queue. This is our coastline. This is some water that's adjacent to our first island. That's going to be our starting point for our bridge. So we'll add it to our next queue. Now our next queue is a little bit different. It's going to have the XY coordinate, but it also keeps track of the length of the bridge so far. So it's going to start as length 1. All right. Once we've found our first island, marked all of its land cells as visited, and built our next queue, then we'll start a new queue. This new queue will start as our next queue. So these are all of the starting points for our bridge. While we still have something in this queue, we'll pop out a cell. We will visit that cell so we don't end up going through this multiple times or using the same cell multiple times. We'll break out the XY and length of that cell or bridge length of that cell. Again, we'll find the up, down, left, right from this bridge cell. And then we'll go through each of these cells, make sure that we have land or we have water, in fact. So we'll go through these cells, make sure that we have that direction, make sure that we haven't visited it already, same thing that we did previously. If we find some land, if we run into land again that's not been visited, that means it must be the next island. And since we got to the next island, we can return this bridge length. Now, you might be thinking, how do we know that this is the shortest bridge length so far? Well, we are doing a breadth first search. So this pop 0 makes sure that we're essentially going breadth first. So you can think of the island as just a blob, and we're kind of tracing around this blob. So we're tracing around the island, filling in all the coastline first. Then we're going to trace around that island, filling all the coastline, and keep expanding this island out and out and out. So it's just like growing out like a mold spore or something. So it'll be growing out until it hits the next island. And the first point it hits the next island will be the shortest possible bridge. Now, if we were to pop -1 here, then we would be doing a depth first search, which would be more like sending a long tail out trying to reach the next island. But that could end up being very, very circuitous, like going in circles and going all over the place. So we really want to do a breadth first search, not a depth first search. All right, back to here. If we ever hit land, that means we found our shortest bridge and we return that value here. If we don't hit land, we know we're at water. So we'll just add that water cell to our queue. We'll process it in the future, but we do need to add 1 to our bridge length at that point. So this new water cell that we're adding to our queue, we can build bridge on it, but that bridge cell will take up 1 more in length. And again, we're going to add that to our visited so we don't end up visiting the same cells multiple times. Oh man, that is a wild one. All right, well, that is it for me. I know this was super fast. Like, I went through this really quickly. It's a lot to cover in a short amount of time. So I recommend maybe watch this video a second time, check out the code, kind of work through it on your own. Try to actually jump in and do this problem. Again, this is LeetCode problem. What is this one? LeetCode problem 934. So yeah, jump over to LeetCode, check it out, and see how you do. All right, I think with a 97% runtime and 54% for memory, I am done with this one. Okay, well, I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.